Hi, I'm Nicole. I worked under Dr. Kara Stepp. I'm in the College of Engineering. She's actually in Sargent, the College of Health and Rehabilitation Sciences. Together with my project partner for my biomedical engineering senior design project, I worked on building a naive Bayes classifier to automatically classify whether some of the high-speed video endoscopy images we were getting were usable for our analysis methods. So just to back that up a little bit, we look at a lot of different voice and speech disorders. So one of the primary ways that we investigate those is through video endoscopy. A small tube is placed either in the mouth or the nose, and then it goes and looks at the vocal folds. And these images are really important, but standard frame rate is only 30 frames per second. And if you hear my voice right now, my vocal folds are moving at about 250 hertz or times per second. So what we're doing is using high-speed videos at 1,000 frames per second to more accurately understand and classify these voice disorders. But this presents a lot of analysis issues, so what we've developed are automated analysis algorithms, and we're looking to aid in that process and reduce the time required to successfully analyze those images by automatically classifying them. So, yeah.
I'm Laura Capozzi. I am an arts education major in the College of Fine Arts, and the focal point for my keystone is about STEAM, which is an emerging model of education in which science, technology, engineering, arts, and mathematics are all used in tandem with each other to create problem-solving activities for students. So through this last year, my senior year, I did my student teaching at 2 schools in the Cambridge School District. And I was able to create a curriculum that hit on STEAM while also working with different teachers of the core subjects and also teachers of the maker spaces. So several of our projects, I'll run through them quickly, and then if you're interested, you could talk to me outside in the poster viewing. But my first graders were able to label parts of a flower based upon their discoveries and observations out in the field and through the process of art making and different techniques we could use. My 4th graders were able to use quilts as a way to convert fractions to decimals to percentages. And my 7th graders were able to use data from the weather to create a series of woven artworks. So if you're interested in any of these projects or the application of STEAM into our education system, please come and see me. Thank you.
Hi, my name is Kayla Furbish. I am a psychology major, and I worked with Dr. Brenda Phillips to look at the relationship between mindfulness and resilience. So childhood trauma has been linked to numerous long-term negative health outcomes, from cancer to heart disease to obesity, drug and alcohol addiction, and mental illness, ultimately resulting in up to 15 years of shortened life expectancy. One of the reasons for these outcomes is that exposure to traumatic stress can result in overactivation of the sympathetic nervous system. So the sympathetic nervous system is responsible for what we experience as the fight, flight, or freeze response. So when you experience stress, your heart rate quickens, your digestion pauses, and your body prepares for action. When you experience chronic or traumatic stress, your body may remain in a state of perpetual fight, flight, or freeze, leading to symptoms of anxiety, depression, or dissociation. Mindfulness is the ability to non-judgmentally be aware of your thoughts, feelings, and perceptions in your body in the present moment. And many studies have shown that mindfulness has been able to improve emotion regulation. Additionally, many structured mindfulness practices, such as yoga or meditation, incorporate breathing exercises, and those breathing exercises can help to calm the sympathetic nervous system. So for my project, I conducted a research study looking at the mindfulness practices, health behaviors, and emotional well-being of women with and without histories of childhood trauma to see if there was a relationship between mindfulness and resilience. If you're interested in learning about my results, you can come check out my poster. Thank you.
Good morning. My name is Kaitlynn Lopes, and I worked under the direction of Mark Grindstaff in the College of Engineering. Although I'm a chemistry major, I really appreciated his guidance and help in the laboratory. My project focuses on non-alcoholic fatty liver disease. This is a disease that plagues 25% of the worldwide population. And in non-alcoholic fatty liver disease, cells become filled with free-floating fatty acids. And what that does is that renders lysosomes, the unit responsible for removal of cellular waste, to become more basic and unable to remove cellular waste. So the focus of our project was to prevent non-alcoholic fatty liver disease from developing into cirrhosis by creating nanoparticles and encapsulating an acidic polymer, which is shown by the branched structure, into a spherical nanoparticle seen on the bottom. So my work focused on the synthesis of these 5 different polymeric nanoparticles and analyzing their potential applications for mouse models to combat non-alcoholic fatty liver disease. So I hope to see you at my poster. Thank you.
Good morning, everyone. So today I'm going to be presenting my poster on hacking HTTP headers for fun and profit that I worked with my advisor, Ari Trachtenberg, in the College of Engineering. So for my thesis, I worked on this new technique to hack people with websites. And so there are 6 possible attacks that we uncovered, and I'll briefly go through them, but if you want to know more, feel free to hit me up during the poster session. So the first thing that you could do with this technique is I can tell as an attacker what's running on your computer or any other computer that you, the victim, can access, but I, the attacker, can't. I can also force you to load content from a blacklisted website in a way that no firewall or antivirus blocks today. I could force you to attack another machine, so I could use you as a stalking horse to do my dirty work. I could also force you to do sketchy things that would get you blacklisted by different antivirus or firewall systems on other computers. And I could use this technique to also track your movements across the internet, so like a browser cookie, but better because this is not detected by anyone yet. And also the last attack is that if I'm your internet provider, I can figure out which other websites you visited, even if I wasn't there to observe these prior visits. So like, let's say you went to a vacation in Russia and you visited websites there, and you come back to the US, and then your internet provider here wants to know what you did over there. So they can use the techniques that we uncovered to figure out what you did, even though they weren't physically present there to, observe any of these browsing visits that he had in Russia. So feel free to come chat with me and learn more about how this works. Thank you.
Hi everyone, my name is Josh Smith-Sreen. I'm a biology major and I'm pursuing my MPH at the School of Public Health as well. I systematically combed through the literature for my thesis looking at digital health technologies that work to target healthcare exchange in lower and middle income countries. So I was looking at technologies that either operate on a mobile phone or don't, but that help people to finance their healthcare and to provide enhanced healthcare provision as well. So you can hear more about my process, my results at my poster, but I just kind of wanted to go through my journey. My project has changed a lot in the last year and a half. So about more than a year ago, I got fascinated by this mHealth technology called mTiba, which helps, it's active in Kenya, and it helps, it allows individuals who are low income to access and pay for their healthcare all using a mobile phone, even if they don't have a bank account. Just that topic fascinated me, and I spent all of last summer kind of networking to try to make a project happen around that technology. And through that networking, I got connected to the Africa Health Business Symposium and actually went to Johannesburg last October to discover more about private-public partnerships in this space. And then through that conference, I was actually connected more to the companies that were involved in mTiba, like Farm Access and CarePay, and actually went to Nairobi, Kenya over winter break to try to conduct field research on this technology. Although that field research and the primary data collection didn't really work out, we can chat more about that in my poster, that did end up with me getting more connected to the Amsterdam Institute for Global Health and Development, which kind of the conversations I had with them sparked my current literature review into the current landscape for digital solutions within this space. So it was quite a journey, and this is kind of my final product from it, but I've kind of built these lasting connections through this entire process, which is kind of what I've gained about the Global Health Research Project. It's all about these partnerships and networking. So yeah, look forward to seeing you at my poster as well.
Hello, I'm Emily OBrien. I'm going to be taking us in kind of a different direction. For my Keystone, I've written the pilot episode of a science fiction drama inspired by the Odyssey. So the first season and the pilot episode sort of have three storylines. Initially, we start with Odysseus and following his journey home. So for him, every planet, every moon, every stretch of open space that he's trying to travel through is presenting new life or death dangers for him. And then back on Ithaca in our second storyline, after Odysseus's presumed death, Ithaca's neighbors, the moons and planets surrounding them, are seeing blood in the water. And Penelope, as the queen, has to expertly manage and manipulate a revolving door of diplomats set upon taking over Ithaca by any means necessary. And then our final storyline, Penelope and Odysseus' daughter, Macy, is sort of coming of age in the shadow of powerful parents. So with youthful overconfidence, Macy has decided to take the fate of Ithaca into her own hands, even if that means destroying her mother's carefully laid machinations. And though she's in over her head, she quickly finds an ally in one of her father's old friends. But whether she sees them or not, she's surrounded by enemies. So if you want to hear more about my pilot episode and my series, you can find me at my poster outside.
Hello everyone, I'm Sonika Vatsa, and today I'm going to be presenting the inhibition of trehalose-6-phosphate phosphatase as a part of the Allen Lab in the Department of Chemistry. So my project focuses on two bacteria. One is Mycobacteria tuberculosis, which can infect your lungs and cause tuberculosis. And it's a pretty serious disease, as it can cause respiratory failure, and millions of people have actually died from it. And then the second bacteria is Mycobacterium marinum, which can cause a skin infection called aquarium granuloma. So both of these bacteria are similar in that they both have the sugar molecule called trehalose, and that basically allows them to be toxic and function as a pathogen. And so the pathway to forming the sugar is the same in both of these bacteria. And my project focuses on T6PP, trehalose-6-phosphate phosphatase, which, as you can see, is involved in the last step in forming the sugar. So I'm working on trying to inhibit it, because if you knock out that protein, then the sugar cannot form and then the bacteria dies. So I'm working on trying to inhibit it for future insights for drug therapeutics, specifically for tuberculosis. And if you're interested in my results, you can visit me at my poster.